Today in this video lecture, we will see stress due to impact load. When a load applied on a body, it falls from a certain height is called as impact or falling load. See, this is W load. This W load falls from this height H and on this collar. Consider a member is fixed at top. This member is fixed at top and collar is attached to its lower end. This is collar attached to its lower end. Let W be the weight of movable load. This W weight of movable load. H height of fall. This is H height of fall. L length of member. This is L from fixed end to top of collar distance L. Length of member A cross sectional area of the member. Delta L is deformation. Due to this load falls from height H to this collar. This collar deforms due to this impact load. Impact acts on this collar, and due to this impact this body change its shape, this collar change its shape, and changing shape is delta L, and this sigma is instantaneous stress. So our problem statement is to find stress due to impact load. So we will see step by step this derivation. This impact load is short interval of time load variation. So our first step of this derivation is work done by the external movable load, and we all know work done by the external movable load is, what is work done by the external movable load? This is load into deformation. So right, first step, this work done by external movable load is, see, this is W load, movable load is W, and multiply by deformation is this H plus delta L. Remember, this H also comes in this formula. Now next is, and we all know that strain energy is equal to work done by external load. So this is nothing but strain energy. The strain energy and work is equivalent. So this is strain energy. And strain energy formula is sigma square upon 2E multiplied by volume. So this W as it is, this H, this delta L is sigma L upon E. Sigma square upon 2E as it is multiplied by volume, that means area into length. Here multiply with W to this bracket, that means WH plus W sigma L by E. So multiply this 2E to the this side, RHS side, sigma square multiply by AL. This is WH multiply by 2E plus W sigma L by E multiply by 2E. This E get cancelled. So also divide this AL to this RHS side. See why we do that? Why we do methodology steps like that? Because our aim is to find this sigma. That's why I separate this sigma one side and all other terms to other side. write this as a 2 E 2EWH, and this AL, this AL plus C, this is W, this is H, this is E, and this AL to this side. Simple mathematical steps. This 2, this side 2. Arrange only 2 W sigma L divided by AL, and see this L also get cancelled. Remaining terms are sigma square is equal to 2E WH divided by AL plus 2W sigma divided by A. Take this to the LHS side, sigma square minus 2W sigma upon A is equal to this term 2E WH divided by AL. Here multiply P by A square on both sides. And see this as A minus B square is equal to A square minus 2AB plus B square. Sigma square minus 2 W by A into sigma plus here P. See this load, and we denote load as W. So here denote W. That means this is sigma minus W by A square. This sigma square minus 2 into sigma into W by A plus W by A square plus take this W by A square this side plus 2 EWH divided by AL. And when we remove this square, what happens? When we remove the square, this is gone to the root. Next step is this. So remove the square. Therefore, our stress for impact load is W by A, here the W by A gets it, plus W by A square plus 2EWH divided by AL. This is stress due to impact load. This is load. This is area. Load area 2, modulus of elasticity E. W load, H height of fall, area of cross sectional and length. And we all see in our previous lecture, stress due to gradually applied load is sigma is equal to P by A, and stress due to suddenly applied load is 2P by A, and stress due to impact load is this W by A plus these terms added to this impact load. And 1C, if we put this H as a 0, that means if we take this H as 0, this H as 0, that means this load is here, somewhere here. And what is this term? This is suddenly applied load, the terminology in this. If we put this H at 0, that means this load comes to here, and this is suddenly applied load, and put 0 here in this formula, you will get suddenly applied load equation. Sigma is equal to W by A plus under root of W by A square. This W by A plus this root and square cancel, this W by A, that means 2W by A, and this stress is due to suddenly applied load. So impact factor, impact factor is nothing but impact factor stress due to impact load divided by stress due to gradually applied load. And stress due to impact load is W by A plus under root of W by A square plus 2EPH upon L, and divided by stress due to gradually applied load is stress due to gradually applied load is W by A. So here impact factor is, okay, this is impact factor. If you solve mathematically, see only this is impact factor, and impact factor another term is suddenly applied load. Here only suddenly applied load comes. Here see, here suddenly applied load term comes, and due to this impact factor suddenly applied load stress, we all know that is 2W by A, and gradually applied load as it is W by A, that means this is 2 impact factor, and this impact factor is always greater than equal to 2. This is important. This is our main formula, stress due to impact load is equal to W by A plus under root of W by A square plus 2EWH upon AL. And how we get this formula? First step is work done by the external movable load, and work done is nothing but the strain energy. And after solving it mathematically, this stress comes. Sigma is equal to W by A plus under root of W by A square plus 2EWH upon AL. So this is our today's lecture. Thank you for watching this lecture.